Hello and welcome to this tutorial on how to make a chain template that's pretty universal. So what you want to do is I'll just do a demo of what it looks like. So I'm going to hit new, chain. The CC here stands for center to center. I hit create. And then as you can see, there's a chain model, and if I hit parameters over here, I can scroll all the way down, and here I can select, I want like say 35 chain. I want, I don't know, like let's say 60 links. And I have 12 to, I don't know what that happened. All right, we have 12 teeth here, and then another set of 12 teeth here. If I hit update, it's gonna update my whole part. And there you go, there's my 35 chain. And if I measure the distance here, it should be 0.375, which it is. All right, so how do you make this template? Now, okay, also part of this template is there's like this coding bit. Basically what it looks like is that drop down menu, right? So if my chain is 25 or 35, this is the pitch. And based on that pitch, we're going to change all these other variables. And after that, we're going to calculate center distance. There's the equation for that, and the radius of first sprockets based on the number of teeth. All right, so how do you make this? First part is to actually make the chain model. So we're going to hit new standard.ipt. Now I have my inverter set up so that when I start a standard part, it goes straight to a sketch. Doesn't matter, you can just create a sketch on any plane you want. Now what I'm going to do is go online and search for ANSI 35 roller chain. And you want to scroll down to this PDF, and you'll see this has a lot of dimensions that you can use to make your chain. Alright, so first we're going to do is make these rollers on the inside, which are circles with a diameter of 0.2. Roller diameter 0.2. Alright, so we're going to go here, make two circles. Now I'm using keyboard shortcuts, which is why you won't see me doing this a lot, but there's some default shortcuts that Inverter comes with, and you can also make your own if you right click on here, ribbon, customize your user commands, and then if you go under keyboard, you can actually change all your shortcuts here, and you can narrow them down to be like just for the sketch environment, right? And here you can have a lot of keyboard shortcuts, but basically back to this. I'm going to constrain it horizontally to my origin, and then how much was this? Still 0.2, right? 0.2, I think. Yeah, 0.2. Now the roller also has the pins going through it, so we're going to make those 0.141. Oh, I forgot. This should be roller diameter equals 0.2. You want to have names for your variables so that you can later use it in your code as well. If you don't do that, you're going to be so screwed. Alright, so we make these two equal. To do dimension pin diameter equals 0.14. Oh, 0.141. There we go. Now the distance between these two circles is our pitch equals 0.375. And then, oh yeah, we need to make these two circles symmetrical. So I'm just going to do symmetrical. That's this constraint, by the way, this one over here. One dimension needed. Oh, that's just a line, so it doesn't matter. All right, finish the sketch. There's our rollers, and how big are they? So this W over here is 0.189, so I'm gonna hit extrude. Symmetrical, make sure you hit symmetric over here because that's gonna help you later with mirrors and assemblies and everything. 0.189, and I want to select this outer boundary here, this boundary over here. And we're gonna make this roller width, or actually, I'm just gonna go off this chart, like whatever they call it, width between link plates. Okay, so that's big. Okay, width between LP equals. Right. Doesn't matter how long it is. It's okay. So that doesn't look much like chain right now, but you'll see. So now what we're gonna do is create a new sketch on this face over here. and we're gonna do is make the plates. So for the plates, just hover around the circle here and you'll get a center point. And same thing over here. You have two circles, make these equal to each other. Um, let's see. So diameter for them is this h over here, which should be 0.355. So I'm gonna go here and plate height equals 0.355. The reason why I'm giving all these variables names is because in order for this to be interchangeable between a 25 and 35 chain, we're going to change all of these variables, so it's much better to have names for them, because if you don't put names, then it's really hard to figure it out. Next thing you want to do is put an arc in the middle of these two, there and there. Now we want the arc to be tangent to these circles, so there, and then we want them to be equal to each other. Okay, there we go. Now, the chart doesn't actually have dimensions for these arcs. I just do to point whatever the pitch is. So I can just do pitch, for example. There we go. That looks good. Now I'm going to select these two inner circles here that are projected geometry. I'm going to unconstruction them because the plates do have that hole in there so that the pin can go through. So now we're going to extrude it by how much? So the width of these plates is 0.049. So I'm going to extrude that circle that much. Don't make it symmetric. And this is our plate width, 0.049. Hit OK. That looks good. Alright, so now what I want to do is mirror this. Now, before I do that, I'm going to slowly double click and rename this to rollers and this to plate 1. Reason for that is when you're gonna have a lot of extrusion and stuff here, and it's really hard to find stuff when everything's just extrusion 1, 2, 3, 4. Now what we're gonna do is mirror this. So mirror this plate. Because you made it symmetric, just select the XY or whatever plane you sketched on, hit OK, and there's your other plate. That's why you want to use symmetric extrusion and everything. And I'm just gonna make this plate 2. Alright. Now what we need to do is make our second link. So what I'm going to do is make a plane on that face and offset it by 0.1 millimeters. Reason for that is in real life as well, the links aren't like right next to each other because there would be a lot of friction then. So hit OK. There's our plane. It's barely away from the other plate. That's what we want. I'm just gonna name it offset plate plane. And what I'm gonna do is make a sketch on that plane. Alright, so we're gonna project geometry of that circle there. So we have that center point. Then we're gonna make a circle there, just like last time. Equal these two to each other, and that should be on construction. We're gonna make another circle here. It's gonna be equal to this other one. Now for the dimension, right? Because we already made the other plate, I can just do plate height, and it's automatically there. That's why another reason why you want to have names. And this is gonna be our pitch. Here we go. That looks good. And just now we need arcs over here, so make an arc there, another arc over here, make these tangent to the circles, and then we're gonna hit equal, and finally a dimension. So we'll make that pitch, and there we go. There's the sketch. Extrude that, and this number should be plate width. There we go. I'm gonna turn the visibility off on that plane, and you can see there's that tiny bit of gap in between. That's what you want, and you have this. All right. what we can do now is rename this to plate 3. And I'm trying to think. Oh, we can just mirror this plate. Mirror cross. Okay. There's our second link plate over there. And then, oh no. This should be plate 4. Now all we need are the pins. So I'm gonna go here, make the sketch visible again. And how big are the pins? They are also 0.461. That's how big they are. So hit extrude, and this time I'm gonna select the inside circles. And I'm gonna select this last option here, asymmetric. And let's see, so distance A, what was this number again? 0.141. 0.141. No, that's not it. It's 0.461. 0.461. I'm gonna have to do some math here. Alright, screw it. I'm just gonna return the visibility off to make a new plane. Do that. So what's the difference here? Oh, no, that's not what I do. Okay, sorry. What we're gonna do is make a new sketch in the middle here, and we're just gonna project this circle and that circle. What just happened? Okay. Oh god. Okay, we're back to normal. Alright, I'm gonna select these two. On construction, finish sketch, extrude that, and there we go. Okay, that looks good. It's 0.461, right? Yes, 0.461. This variable should be pin length equals 0.461. Hit OK. And there we go. We have our pin, we have our plates, and we have our second bit that we needed. Alright, that looks good. Let's name this pin. Alright, I'll set the material to be, it's cast iron. Yeah, that looks good. Now we can do is make a fillet on 0.1 millimeters. G2 fillet. And let's see, what are we selecting? That edge. Now this step you don't really need to do it. It just looks better. So just doing that for purely aesthetic reasons. I'd apply. Yeah, it looks a lot better. Nice crisp. All right. So now what we're gonna do is create a sketch for the path this chain's gonna take. The reason for that is, after that we're gonna do a rectangular pattern of these links around in a loop, and to do that we need a path first. So we're gonna do start a new sketch in the middle, and what we're gonna do is, so if you press F7, it can like slice the graphics, but I know on some computers it won't let you do that. It'll like pop something else up. So what you can also do is go on view and slice graphics, and then you get this much easier to work with. So what I'm going to do is I'm going to go back to sketch, project the geometry of the circle, that circle, make a construction line in the middle. Right, and then the midpoint, I'm going to put a point there, over there, and that's where we're going to start everything. So we're going to have a line over here, line over here, some arbitrary amount, doesn't need to be any dimension, and then we're going to make another line somewhere over here. We're going to make an arc from that point to this point, and same thing over here. You could do this with a slot, but then the problem with the slot is that two arcs are equal to each other, so that's what I'm just doing. Two arcs in a line and two lines. Make the arc tangent to each of these lines. And there we go. Alright. So now we're gonna add some dimensions. So this distance over here is the center to center distance. Center to center. Make sure it's a diagonal dimension. So center, I can just do CC distance equals, I don't know. We're making 35 chain. I'll just do. So I'm actually gonna do is go to this calculator over here, Botlana chain calculator. It should be in the important links folder. 0.375. Let's do a 12 tooth, 14 tooth, and we want say 30 links. That should be our center distance. I'm gonna copy that over to inventor and paste. It's just an arbitrary distance for now. That we can change because this is a template anyway. This over here is going to be our small sprocket radius, which if you're wondering where I got the 1.432 from, is close. If you go on Wexpro 35 sprocket, oh god, okay, I don't have it. Wexpro, there we go, 35 sprocket. If you go under the drawing section, all sprockets with hubs, the 12 tooth pitch diameter is 1.432, and oh, there's actually not a 14 tooth. That's surprising. And the next one is 1.79, so I'm gonna have to change this. I'm just doing this because it's an arbitrary value, like so. I'm gonna change this to be that, and this pitch diameter over here was 1.79. So I'm gonna go here. Big sprocket radius equals 1.79. That's just for now, and when we make our whole template, it will be different. Right, it says one dimension needed. Oh, all right. There's the sketch. Now we have our path that we needed. So what we're gonna do is rectangular pattern. Features. I'm gonna do this plate, that plate, those two. All right. And our direction is gonna be this path over here. As you can see, makes that little thing over there. So we said how many links? 30 links, right? So the 30 links is these two parts combined. So this is actually gonna be, I'm gonna make this pattern links equals 30 divided by 2. Right, you can see that pattern links equals 30 divided by 2. Now for here, if you do curve length, what that means is it's going to take however many instances you have of your pattern, and it's going to evenly spread it out along the length of your curve. Now we're going to hit these arrows over here, and if you hit direction 1, it's going to make it like follow your curve, direction of your curve. Now as you can see, it's like messed up over here. For that, we're going to do is select a starting point, and right now it's picking up that point. We want to pick up this point over here, the center point, and now you can see it's how it should be. I'm gonna hit OK, and there's half of our chain. Now we want the other half, so I'm going to do another rectangular pattern, select this outer bit, select the pins, select that other outer pin. All right, direction. Oh, what we actually need to do is take this sketch over here and make it visible. I'm just going to rename it to if it's not visible, you won't be able to do the rectangular pattern. So let's do this again. Select the plate, the pins, and then for direction, we're going to select the path. So there we go. Same thing. Now I have the variable name, so I can just do pattern links, curve length, direction 1, and it automatically good to go. Hit OK. And there is our chain model. that is solid and good to go. Another thing you want to do is add points here, because in your assembly, when you put everything together, it won't pick up the sketch points. You want to have these points, so these work features over here. So you can just do that, use that to constrain it to your sprockets. There we go. You can disable, turn the visibility and the path off. And if you make your middle plane visible, when you're assembling, it's easier to work with it. All right, do I have names here for most of the things? All right, that's how you make your chain. And you can save this as a template for 35 chain. You can just use this the whole time. Like if you go in parameters, right? You can change how many links you have. You can change the size of your sprockets, and you won't ever have to do anything else. But because we want it to be a universal sort of template, what we're gonna do is we're gonna do plus iLogic, and then we're gonna do right click, add rule, and we'll make this chain, just chain, doesn't matter. Hit OK, and it'll take you to all this. Now this is where we're gonna do our Cody bit. Oh, actually, before we do that, we want to add variables here that we're going to change. So where it says user parameters, we're going to add a numeric variable. So it's going to be called big sprocket teeth. So it's the number of teeth on the big sprocket. Okay, add numeric big sprocket teeth. And it's going to be unitless. Hit OK. And put like 12. Oh no, 14, 15. That's what it was. Add another numeric small sprocket teeth. Again, we want this to be unitless. Hit OK. Make it 12 for now. And then we need a number of links. So links, that's again a unitless value. Hit OK. And we'll make this like 30. And now what we're going to do is add a text. And we want it to be chain type. And if you right click, you can make it multi-value. And here I'm going to add 25 chain, 35 chain. Add, hit OK. And now it's going to be a drop-down menu. Right? You have these variables, you can add a comment here like number of teeth on big sprocket. It just helps in case someone is using your template and they're kind of lost. Small sprocket, number of links in the chain, and 25 or 35 chain. Alright, we have all that. You press done. Now we're going to create an add rule, chain, hit OK. We get here. Now, first thing you want to do is if. So what you can actually do is you can just press here, and it'll add all the if stuff for you. Alright, so here if. Now what you can do is go over here, and you can get these user parameters. What are they called? So if our, let's see, chain type equals, is that how you do this? Operators. I think it's just equal. Is equal to 25 chain. Oh, I need codes there. 25 chain. Okay, I'm just gonna open. Oh no, I can't do that. All right. Equals 25 chain. Then our pitch is equal to 0.25. And again, you can view that if you go model parameters, pitch. That's what it's called. That's what it is. 0.25 inches. And then just add else if, so no else if chain type is equal to 35 chain, and like the code editor thing on this just automatically indents, formats everything, so that's kind of nice. 0.375 inches, and we can end our if there. Okay, so now what we're gonna do is, oh god, that guy is here. So what we're gonna do is pull up the PDF for ANSI 25 roller chain. This PDF over here, so that we can get all these numbers that we needed. So let's just do 35 first because we already have all the numbers. Alright, so if our chain is 35 chain, this is our pitch. Our roller diameter is going to be 0.2. I'm just looking over there for the numbers because we already made 35 chain. Pin diameter should be 0.141 inches. We have already our pitch. Width between link plates equals 0.189 inches. And that's a random dimension. Plate height equals 0.355 inches. Plate width. Oh god, I can't spell. Plate width is 0.049 inches. And let's look down here, plate width. So the rest of this is parametric. Alright, so then we have our pin length equals 0.461 inches. And the center and sprocket and all that can depend later. So that's all the stuff we need to define our chain, or the profile of it at least. I'm gonna control and paste here, and now we just need to change these numbers. So if I go on this 25 chain document, the roller diameter is 0.13. So I'm gonna go here and change this roller diameter to 0.13. Pin diameter is 0.091. Go here, make our pin diameter 0.091. The width between our link plates, is 0.126. Change that to 0.126. Now this is why you want to have variable names, because otherwise this would all be like D1, D2, D3, and you would be so lost. Right, and then plate height is this, there we go, 0.23. So plate height 0.23. The width of our plate is 0.03. 0.03, and the length of our pin is 0.307. 0.307. There we go. So that's gonna define all of our chain. You can save that. Alright. Now after that, this is where we want the equations. So we're gonna calculate like how the pattern basically based on these these three numbers over here. So for that, what we're gonna do is, if you search like chain center to center distance calculator kind of thing, what you get is one of these links. It has this equation over here, this big equation to calculate the center distance based on the number of links. That's the chain length and pitches, the pitch of the chain, and the number of teeth on the large and small sprocket. This is the same equation that this Botliner calculator uses, and I've tested that, so you can use this. So for this equation, what we're going to do is, we're just going to write it out. So our center to center distance, right? Our center, how do I make a new variable on this? I actually don't know. I don't remember. How do you make a new variable? Do you just make it equal? Wait, okay, I actually don't remember. I'm gonna open my, oh, where is it? Oh god, I need to go through this again. Users, public, documents, Autodesk, templates, and US. There, okay. I don't remember like how you make a new variable. Let's see, down here. Oh, you don't actually have to define or anything. You can just straight up do that. Okay, that's good. That's good. All right. So we're gonna edit this rule here, and we're gonna go here. So our model center to center distance is called what? CC distance. All right. So CC distance is equal to, and now we have to insert the big equation. So it is starts with the pitch of the chain divided by 8. So it's gonna be, oh, sorry for the noise. It's some guy with the blower thing. All right, pitch divided by 8. I'm just gonna put parentheses around everything so that it's super duper clear, at least to the computer. It's gonna get messy. So pitch divided by 8 times 2 times the number of links. Okay. All right. 2 times the number of links. Is that the parameter? Is there a parameter? Yes, it's capital links. Okay. 2 times links. It's already getting messy. 2 times the number of links minus the number of teeth in the large bracket. So minus big sprocket teeth. Maybe it was not a good idea to make all these variable names like super duper big. Small sprocket teeth. Okay. All of that. Okay. Plus. We're gonna add square root. So on the left here you have like all this stuff here that you can use if you're confused. So like square root, it will insert, it should insert something or not. Okay, but you can basically see like what they're called. Plus square root, and it picks it up some number. Did it pick it up? Okay, I'm not sure. Square root. All right, it did pick it up. Okay, square root of, what are we taking square root of? The same 2l minus ln thing. It's squared this time. So more parentheses. Great. 2 times number of links minus, this is why I said it gets really messy, because I used extremely convenient long variable names and this is like so annoying, but just keep it like fairly clean and it should be okay. So we have 2 times the number of links. I'm gonna put parentheses just in case. So this is, it matches with that parentheses over there. 2 times, so this is that whole number, and I need to square this now. So can I do that? Can I just add a, oh wait, I don't think that's how. Okay, you know what I'm gonna do? This is so bad. I'm gonna copy all of this over here. Stop. Okay. Copy all of that. Control C. And I'm gonna multiply it there. So we have this big Chungus equation just to say. I'm just gonna wait for that guy to go. I'm just gonna close my door. And it's still just as loud, doesn't matter. Alright. So we have that whole square thing over here. And now what do we need? We need minus 0.810 times some number. So minus 0.810 times big teeth minus small teeth squared. So, oh, this is gonna be so fun. Big sprocket teeth minus small sprocket teeth, all of that squared. This is such a pain. Such a pain. This is why you don't wanna, you just wanna make this template once and make it correctly so that you don't have to go through all this ever again. Why does Inventor not let me select it correctly? Okay, Control C, and we just need to square it. So we're just gonna multiply it again. All right, looks to be good. And I'm gonna add a parentheses there. Add a parentheses here. Right. So that's our squared bit over there, and this is our 0.810 bit over here. And it's getting subtracted from this whole squared thing of the sprocket stuff, and all of that is inside a square root. So we're gonna put this last set of parentheses here. It helps that the inverting highlights the parentheses for you, so that's so much easier to figure out. Alright, all of our square root stuff is in the parentheses. And that's it for the formula. But this is added to the square root thing, which is all then multiplied by p over 8. So basically just have to add more parentheses. So we're gonna add 8 parentheses over here at the very end. And that should match with 8 parentheses all the way at the end over here. That whole parentheses covers the entire square root bit, this 2l minus nn thing, and the pitch divided by 8 times that. Okay. I have faith that this is going to work. I'm going to save it. Alright, now what we need to do is get the radius for our sprockets. There's a small formula for that. I was going to look at my old template because I just searched it up. I'm too lazy to search it up again. Basically, the radius of your sprocket is number of teeth times the pitch divided by pi, all divided by 2. Oh yeah, because it's the radius, because that gives you diameter, then you want to divide by 2 for the radius. Okay, we're just going to add that. So, edit rule, and let's scroll all the way down, and our model parameters are small sprocket radius. So, small sprocket radius is equal to, let's see, our small sprocket teeth times our pitch, right? And then we divide that by 2. No, we divide that by mat dot pi. And we divide that all by 2 because this gives you diameter. And so you want the radius, which is just divided by 2. Copy all of that. Control C, Control V. And we're just going to change this to big sprocket radius equals big sprocket teeth times pitch divided by mat dot pi divided by 2. Okay. And do we need anything else? Yeah, we didn't use links yet, Did we? Oh yeah, yeah, yeah. Okay, okay. Um, so we want pattern links equal to the number of links the user enters divided by 2 because that's how the pattern works. Okay, this should work. It should hopefully work. All right, let me check. Let's go parameters. Let's scroll down. 35 chain. Let's make this 12 tooth. Make this 12 tooth. I want 16 links. Oh yeah, these values look good. Hit update. And it updates correctly. There we go. That's how you make this template. And then you can just do a file, save, don't save as, file, hit this arrow here, or just hover, save copy as template, and just give it some name you want. And that's how you make chain.